Bismillahirrahmanirrahim. In this session, we will discuss parallel and perpendicular lines. And parallel lines have same gradients, and there is a connection between the gradient of perpendicular line. If a line has a gradient m and a line perpendicular to this has a gradient minus 1 over m. If a line has a gradient m and a perpendicular line on that line has a gradient minus 1 over m. So the product of the two gradient is minus 1. So if the gradient is m and the perpendicular line gradient is minus 1 over m, so when we'll multiply the one line and its perpendicular, and we will obtain this minus 1. So this parallel line has the same gradient, and you learn this thing. So if a parallel line y is equal to mx plus c will be of the form y is equal to mx plus d, where c are constraint are constants. So c is just constant. If parallel lines, we have the same slope. If a line is perpendicular to yx is equal to mx plus c, it will be y is equal to minus 1 over mx. So these lines are perpendicular. So because their slopes are the slopes products gives minus 1, and these are the constants or intercepts. So in exercise 27.4, if the lines AB and BC, this AB and BC are the two sides of the square ABCD, find the equation of the line AD. So we have to find the equation AD here and find the equation of BC here, and find the coordinates of D, the D points. So which of these lines are parallel? So you see this in the third part, and similarly other part. So let's start with this in the diagram ABCD. So we have this A, B and C, and we don't know the D and C points are not given. So the C point is 4, 0. A, B, C are given, while the D points are not unknown. So find the equation of AD. So this AD is parallel to BC. This gradient of AD will be the same as the gradient of this BC. So y is equal to mx plus c. AD will be the equation of BC, will be parallel to BC. So AD will be parallel to BC. So gradient of BC is equal to 2. So the gradient of AD is equal to 2. So the equation line is AD is equal to MAD x plus c, and AD is passing through this 2, 6. So this 2, 6, so we will obtain this c value, and c is obtained as 2. So the equation of AD is 2x plus 2 or 2 bracket x plus 1. So the same, and find the equation of the line DC. Since DC is perpendicular to this AD, AD is perpendicular to AD. So this AD is this, so y is equal to so DC is minus 1 over AD is equal to minus half. So because this is 2, so it is minus half. So MDC is equal to this. So MD is minus half, and this is intercept value D, small d, and we have this is passing through this. This line will pass through this point 4, 0. So this at 4, 0. We have this D is equal to 2. So the equation of CD or DC, this line equation will be this minus half x plus d. So on solving these two equations, so we have obtained this line equation and this line equation, and on solving this we will get this coordinate points. So we will solve these two equations, this one and the other one earlier, this. So we solve it simultaneously, and we have obtained this results 0, 2. These are the coordinate of D is 0, 2. Which of these lines are parallel and perpendicular? So this A and y 4x minus y is equal to 5. So y is equal to 4x plus minus 5. So these slopes and gradients are same. So these are parallel. They have the same gradient. 2x minus 3x is equal to 5 is equal to 4, 6y minus plus 4x is equal to 1. So this 6x is equal to minus 4x plus 1. So y is equal to minus 2 upon 3x plus 1. And this is gives minus 1. So these two equations are perpendicular to each other. And find the equation of the line that passes through the 1, 5 and is parallel to this. So find the equation of the line that passes through this and parallel to this. So the slope is same, so parallel lines. So we will take this 3x and we'll write t, and we'll passing through this point 1, 5. So we'll pass it from 1, 5, 1, 5, and we have this obtained d, and this. So this is the required equation. Find the equation of the line that passes through 0, 3 and is parallel to this line. So this line slope is obtained as minus 3 upon 2 plus 7 upon 2. So this slope will be same for this required equation. So right, for required equation we have minus 3 upon 2x, and this is d, and that pass through 0, 3. So 0 and 3. So on 0, 3 we have d obtained as d is equal to 3. So the required equation is this. And part find the equation of the line that passes through 1, 5 and is perpendicular to the line base. So this slope is 3, so the perpendicular slope is minus 1 upon 3. So this is minus 1 upon 3x plus c, and that passes through 1, 5. So we'll write 1 and 5. So 1, 5, 1 and 5, and we have obtained e is equal to 16 upon 3. So 16 upon 3. So this is the required equation. Sixth part, find the equation of the line that passes through the 0, 3 and perpendicular to this. So we'll write this equation in this form: a standard y is equal to mx plus c form. So this is minus 3 upon 2x plus 7 upon 2. So m is this minus 3 upon 2, and the reciprocal or the perpendicular line will have this kind of slope. So this slope is this 2 upon 3 plus x passing through 0, 3. So 0 and 3. So 0, 3 we have obtained this f is equal to 3. So y is equal to 2 upon 3x plus 3. So this is the equation. Find the gradient of the line perpendicular to the line joining each of these pair of points 1, 2 and 5 minus 6. So the gradient is obtained as minus 2. So this is y is equal to minus 2x plus c, and this is passing through 1, 2. So 1, 2. So this c is obtained as 4, and so y is equal to minus 2x plus 4, and the line perpendicular to the given lines have gradient is 1 over 2. So y is equal to 1 over 2x n plus t. If passing through 1 and 2 as given this, so from this we have this obtained this d value, and you place this value. So the required equation is obtained. Similarly for the other parts. In equation, the two lines crosses the right angle to each other, point this, and one passes through 6, 0. This, and the gradient of the line L1 is this minus 3, and the gradient of the line passing through L2 is the right angle is 1 over 3. So the equation line L2 is d, and line passes through 5d, 5, 3. So the d value is obtained, and y is equal to this equation. So this is very important, this kind of questions. We draw this diagram, and so first of all that we have to conceive the equation and the actual what is the requirement. And this is a very important topic from examination point of view. In the next session we will discuss another chapter.